Welcome back to your review for your Algebra 1 Semester 1 final exam. We're on to problem 11, which has to do with solving absolute value equations. Just a reminder, if the problem on your paper doesn't match up with the same number as the one here, that's okay as long as it's the same problem. So, I'm actually going to give you three different ways to do this problem. Two ways are using algebra, and then the third way is going to be just using guess and check, because it's important to be able to guess and check your answers if you forget how to do it. But we'll start with the two algebraic ways first. I think most teachers will probably show you, and maybe I can call this method 1. Most teachers will show you how to isolate the absolute value, and that's what I'm going to call it. I'm going to say isolate the absolute value. So when we do this, we start with the problem, -2, absolute value, x plus 3 plus 6 equal to 10. And the idea here then is that we need to, before we try to figure out how to isolate x, we just want to isolate the absolute value, because absolute value throws things off a little bit. So if I want to start isolating the absolute value, I notice that it's being added by 6 and multiplied by -2. We know we generally undo addition and subtraction first, so we're going to go ahead and undo that adding 6 just by subtracting 6 from both sides. And we end up with -2 times the absolute value of x plus 3 is equal to 4. There's still the -2 that's multiplying, so of course we're going to divide off the -2 and end up with the absolute value of x plus 3 is equal to -2. Now at this point you should realize something about the absolute value. And the thing you should realize is that absolute value is always going to make your answer positive. So for example, let's pretend x was 7. If I did absolute value of 7 plus 3, we simplify the inside to make that a 10, and the absolute value of 10 is 10. Alright, what if I use -7? -7 plus 3 is -4. The absolute value of -4 is +4. So we should be able to see that whatever number we plug in for x over here, at the end, this whole thing is going to end up being a positive answer. However, here's what this is telling you. It's saying after you do the absolute value, your answer is, well, your answer is -2. Is there any number you can think of that when you plug in here you get -2 as an answer? And I can't think of anything because absolute value is always positive. So I'm pretty sure the answer is going to be A. However, let's say that you didn't notice that. You're so set on solving the equation that you're like, okay, I know what to do next. After you've isolated the absolute value, my teacher told me that now I need to make two equations. Right? And this would be x plus 3 could be -2, or x plus 3 could be +2. Because the idea here is that we can have two inside answers here, either +2 or -2. And then we solve each one. We get x equals -5 from subtracting 3, and we get x equals -1 by subtracting 3. We end up with two answers. And notice they're being very clever here because they gave you those two answers. They're expecting you to continue to do this. And so then you have to think, well, how would I know those aren't the right answers? And the answer to it is, well, how do you check to make sure an answer is right? And the answer to that is you go back to the original equation and you plug each answer in. So if I wanted to check this, I'll just check one of the answers and you can try the other one. Let's say I wanted to check x equals -5. Well, I have -2 absolute value. There's an x that we'll get to in a second, plus 3, plus 6 equal to 10. But instead of x, I'm replacing it with -5. And now we just follow PEMDAS. I'm going to simplify what's in the grouping, what's in the parentheses. And then I'm going to do the absolute value, which is like applying parentheses. The absolute value of -2 makes it +2. And because the -2 on the outside was multiplying, I need to keep the multiplication. I need to multiply from PEMDAS. And then add them together. 6 minus 4 is 2. And we end up with 2 equal to 10. And we should hopefully know that 2 is not equal to 10. And you'll actually find if you try the other one, you'll get just about the same thing. You'll get exactly the same thing, and neither of them end up working. These solutions that don't work are known as extraneous solutions. They're solutions we found by using a method, but that didn't actually work in the original problem. So if they don't work, we don't actually have them as solutions, and we end with no solution. Now I wanted to give you a second way to try this as well. And the second way I like a lot. The second way is we're going to immediately make two equations. So method 2 is going to be change the slope. And when I say change the slope, if we look at that original equation, which as a reminder, was negative 2, absolute value x plus 3 plus 6 equal to 10. If I change the slope, well, you're like, what's slope? Well, think about this line right here. This line's in HK form, right? M x minus h plus k. We've been doing that for a while at this point. So our slope in this equation is negative 2. And what we've seen before with absolute value with that V-shaped graph is we can actually make two different lines to make the V, right? This V-shaped graph has a line with a positive slope and a line with a negative slope. So I'm going to go ahead and split this really quickly. I'm going to split this into a line with a positive slope and now parentheses because we're dealing with a line, and then a line with a negative slope. And I should have done parentheses. And the reason that I'm using parentheses instead of absolute value is because this V-shaped graph is just two different lines. We have a line with a positive slope, keeping the blue there, and then we have a line with our negative slope. And notice positive slope, negative slope, and lines are always equations that use parentheses, not absolute value. So now I have each line, and all we need to do is go through and solve. Now the issue here is you're going to get the same answers that we got up above. You're going to get that negative 5 and that negative 1. And so you still have that same issue of after you get answers for absolute value, what do you need to do? Oh, you need to check your answers, and check your answers. So I did mention there are three methods for this problem. I showed you the most common one, that's method 1. I showed you a method I really like, which is just changing the slope, and then you can solve, right? In solving, you just distribute, do your normal thing, 2x plus 6 equal to 10. We'll finish off one of these just so you can see it. 2x plus 12 equal to 10. Subtract your 12 to get negative 2. Divide by 2 to get negative 1. And notice that's the exact same thing that we got up above, just doing it a different method. Of course, the most important thing is checking your work, and if you had enough time on your test, you could actually take this 1 that's here, plug it in and see if the left side equals the right. It won't. You could take the negative 5. It won't make the left side equal to the right, and then you've already checked negative 5, so you've eliminated all your options and still end up with no solution.